Okay, fine. Let's come to the last part of the project. I think you already worked a lot on the AMPL, on the MATLAB, on the VANIC, etc. So congratulations, you have worked through all this kind of difficult tasks. And then let's do the last part. So basically, we will give you a model. So in the folder like this way. So basically, it's the same with before, but we made some small modifications in the .5 in the modifier, and we add all new buildings and different technologies. For example, if we go to the main modifier, so here is the definition of the set, definition of parameters. So I have to emphasize that the difference of parameters and variables in AMPL, because parameters really a concrete value, where variables is something unknown. It's decided by the solver. So basically, it's a result. So sometimes you may get confused in this model because we defined some parameters, some variables. Sometimes it's not that easy to distinguish. So basically, you need to pay attention to that. And for variables, you can't put any value before. So that's important. And here is some definition. For example, heat is medium temperature heat or low temperature heat, and different variables, and then different constraints. For example, here is F mult T, basically the staff capacity and the production of each technology at each time. And then it's a constraint, basically supply equals to demand. And then at last, for example, here the investment cost, operational cost, but pay attention that the investment cost should be linked somewhere to a reference sizes of each unit. Basically, it's a parameter Q heating supply and E flow out, for example. So basically, for each technology, you can, for example, we can check the PV. So basically, the flow out is the reference sizes of PV. And for heating, sometimes for different, you pay attention to that. Q heating supply is the reference sizes. So basically, when you link the investment cost, you should pay double attention to that. Because if you just put the specific cost expressed as how much franc per kilowatt hour or something like that, it's wrong. So basically, if your reference size is 10 kilowatt hour, your investment cost should correspond to your reference sizes. And if you want to change, for example, if you want to do some modifications by adding the CO2 cost here, so basically you can directly add a new variable and then add it to the object function. And the first step you should do, in fact, is to integrate your result of part 3 and part 4 into our model. So basically, it's in the heat pumps. Here, in fact, you have two methods to integrate this kind of data into your MILP model. So, for example, in this file, low temperature heat, one-stage heat pumps, I define it in a way that, for example, the efficiency of heat pumps equals the exergy efficiency times the Carnot factor of your model. So basically, you can change that. For example, exergy efficiency. So in this morning, I see all the groups have done the theoretic COP and real COP. So basically, you can calculate the exergy efficiency easily. And if you want to directly put a value here instead of input this kind of formula, you can directly, for example, in the file, you can directly put a value here. So it's your choice. You can do whatever you want in this part. And to calculate the investment cost, etc., basically you can do as TV has explained just before. So basically by decomposing the whole system into single components and add them together to get the investment cost. But if you have some data already take into consideration all these components, you can directly put one value instead of doing that. So basically, it's your choice. And what else should I see? I think more or less it's there. Maybe I will show you, for example, how I calculate some investment cost for certain technology. So basically, we have some data expressed as, for example, CM1 franc and CM2 franc per kilowatt hour. Then you need to take into consideration the lifetime of the technology, and for example, interest rate, etc. Transfer the unit, and then get the annualized investment cost. So basically, you should do this way, or you can put, for example, here. You can put a formula or something like that into your MILP model. So that is another way to do that. Then you can, for example, directly change. For example, I want to say the uncertainty of interest rate will be brought about on the system, and then you can directly change the interest there in the model instead of doing it manually. So basically, we give you the flexibility to do that. And if everything goes well, you run the model. So, this is the result. So basically, yeah, I mean, sometimes I just see the object function you get is how much billion, something like that from Swiss. But basically, that is something, I mean, maybe you get something wrong with the investment cost or operational cost expression. So basically, I mean, you double check that. So yeah, I mean, then you can, for example, do some sensitivity analysis of the cost of the prices of, for example, the natural gas, electricity, and integrate CO2 into the model, and then how to say, draw the Pronto graph, etc. These kind of things. So we need you the freedom to do that. Do you have any questions on this part or not? No? So in case you have any questions about program, just, for example, asking us. And next week, all the teaching assistant will be here. So basically, you can ask all the questions as you want. Right?
Yes.
I see something wrong, I'm afraid.
No. Sean, maybe we can just explain some results.
Yes.
So can you just go down, scroll down? So here, as you can see, you have like the heating demand sorted per building. So all of you had like only like 4 buildings to analyze. But we're just implementing all the data for all the buildings. So that's the reason why you have like building 1 to 24. And here you can see that we have considered like 5 typical periods, and these are like the heating demand for the 5 typical periods. If you go down, you can see that we have like implemented in our solutions, we have cogeneration, the possibility to buy electricity, geothermal. Can you go down a bit more? And for example, for this specific solution, if you take a look at flow in units, this is like the amount of the resource that actually goes into your unit. So for example, we are buying at the moment 6,399 kilowatt of electricity. So it's a bit difficult, it's a small number. And you have like natural gas for the boiler and for the cogeneration units. So you're at the period number 6, you're importing 11,111.1 kilowatts of natural gas. And at the same time, from the cogeneration unit, you know that you're producing electricity and heat. And in the first period, you are producing 12,581.7 kilowatts of electricity. So when you actually analyze each solution, you can have a look at these kind of variables, flow in unit, flow out unit. You should have the same from your MILP, so I assume that most of you already know that. And you can have a look at what is like the share between the different energy technologies and sources that you're using. Yes.
And for example, here you can see that the boiler for them only appears in the extreme scenario. So basically, it's in accordance with the case that boiler is just as a backup for the moment as a heating supply demand. So basically, you can do some analysis on the result. But our result, I have to say, is not unique. The investment cost research, in fact, we did it as you to do a lot of literature review, etc. So basically, your data may be better than us. It's not obligatory to have the same data as we.
And what did you minimize? Was it like the investment cost this time?
Can you show minimize the total cost instead
the total
of
cost,
the.
Okay. Julia?
Yeah, so that was my question, but this is still not multi-objective, right? This is still like one
Single objective.
Yeah.
What you need to do is to integrate the CO2 part by adding, for example, a new variables, etc. But that is something, I mean, not difficult compared with the first 4 scenarios, basically.
Because in the end, what we want is we want a Pareto plot over
Yes, we want.
between 2 objective functions that are not necessarily that are contradicting each other,
Exactly.
right? But right now, this is just a single objective,
Yes.
which is what is the total cost and investment cost?
It's a
like
total
the sum
cost.
of the total investment cost annualized and the operating cost.
Yes. So questions? Okay, perfect. Then
Julia, do you know if we have like another room, or we just have this one this time?